Now we want to put the things we've learned about factoring polynomials to work to solve equations. So here I have solved this equation that's in factored form. X times x plus 1 times x minus 3 is equal to 0. Well, the zero factor property tells us that we can't multiply three numbers and end up with 0 unless we have multiplied by 0. So the only way this product comes out to be equal to 0 is if x is equal to 0, or x plus 1 is equal to 0, or x minus 3 is equal to 0. So if x is equal to 0, that's one solution. X plus 1 equals 0, I add negative 1 to both sides and get x equal negative 1. X minus 3 is equal to 0, I add 3 to both sides and I get x is equal to 3. So here's three numbers, each of which is a solution to this equation. If I let x be equal to 0, I have 0 times, it doesn't matter, I end up with 0. If I let x be equal to negative 1, I have negative 1 times negative 1 plus 1 is 0, so it doesn't matter what comes next, the product is going to be 0. And if x is 3, this factor right here is 0. 0 times anything is going to give me 0. So here's my three solutions, and I find them by taking this factored form right here and setting each of the factors equal to 0. Now, if my original problem isn't already in factored form, then I'll put it in factored form. Standard form is when I have decreasing powers of the variable on the left side and 0 on the right side. Once it's in that form, then I can factor the left side. This should factor nicely into x minus 4 times x minus 5. Inside I have minus 4x, outside minus 5x. They add up to negative 9x. The only way I can multiply these two factors and get 0 is if x minus 4 is 0 or x minus 5 is 0. If x minus 4 is 0, then I add 4 to both sides. X is 4. There's one solution. If x minus 5 is 0, I add 5 to both sides. I get x is equal to 5. There's my second solution. Let's just check one of these real quick. If I take x equal 4 into my original equation, I have 4 times 4 is 16, minus 9 times 4 is 36. 16 minus 36 is minus 20, plus 20 is 0. I end up with 0 equals 0. So you can see it does work. My next problem, I need to do a little work to put it in standard form first. So what I do is add negative 10a to each side, and I have a squared minus 10a plus 25 is equal to 0. This is a perfect square trinomial. It's a minus 5 times a minus 5 equals 0. If I set either one of these factors equal to 0, I get the same solution. A is equal to 5. So only one solution to that, the number a is equal to 5. If I substitute that back in up here, you see I get a true statement right away. My next problem, x squared plus 6x is equal to 0. Let's try factoring by factoring out the greatest common factor. I have x times x plus 6 is equal to 0. Set the first factor equal to 0. Set the second factor equal to 0. When x is equal to 0, that's one solution. When x plus 6 is 0, I add negative 6 to both sides and get x equal minus 6 for my second solution. So this one has two solutions. Either one of those you can check real quickly by substituting them for x, and you'll see you get a true statement. Here's my last equation. It is a cubic. I see that I have a greatest common factor of what? 2y. So I'll take that out. What's left is 2y squared minus y minus 15. I continue to factor, and I end up with, let's see, 2y and y. And let's see, I can multiply here and get 15, and I want to add inside and outside and get minus y. So how about 5 and 3? Inside is 5y, outside is 6y. I want this to be minus 1y, so I'll make the 6y negative and that positive. Now I have the product of this, this, and this equal to 0. So 2y is equal to 0. That's one solution, or 2y plus 5 is 0. That's a second solution, or y minus 3 is 0. That's a third solution. 2 times y is equal to 0 means that y is equal to 0. There's one solution. 2y plus 5 is 0. I'll add negative 5 to both sides, then divide by 2. I get y is equal to negative 5 halves. There's my second solution. Over here I'll add 3 to both sides and I get y is equal to 3 as my third solution. So a little bit more complicated problem. I had a little factoring by grouping first, then I factored this trinomial into the product of these two binomials. Now I have 1, 2, 3 factors to set equal to 0. I get 0. I get this fraction minus 5/2 for one solution here, and then this other solution, y is equal to 3. So that's how we use factoring to solve equations.